Today we will study about delta to Y transformation or Y to delta transformation in our electrical circuit chapter 2. So in this you can observe this diagram. In this diagram, if you see the nodes and the resistance, this is slightly complex circuits than the series parallel combination. How it is complex? So if you see this node on the right side, R3, R6 are connected and R4 are also connected to this node, and these three are generally parallel, but that we cannot solve direct parallel equation here, and we cannot use that two resistance in parallel, then again two resistance in parallel. We cannot solve that one. Why? Because for any circuit, if two resistors are in series is known by if they are connected to the common node. If they are connected, only two resistors are connected in that node, then they are in series. Like R4 is not there, for example, then R3 and R6 are in series because they are connected to this node. Now R4, now what is a parallel? Now parallel is nothing but when they are connected to two or more resistances in the particular node, and it must share the other side node also. The same resistances must share the resistance, must share the node. Other side node, these resistance must share same thing, same like the first node. The second node also, the same resistance should share it. So then it is called a parallel. Now here this node R3, R4, R6 are connected. Now this node, then R6 is connected, but R4 and R3 are not connected. So these three, R6, R4, R3 are not parallel. It's parallel, but it's not, we cannot solve direct parallel equation or rule method. So that's why we came into picture to study about Y and delta transformation. So what is delta transformation? Many, okay, there is Y or T type. So generally one type of network called Y or T type, or another is called delta or pi type. How? First you study what is Y and T type. Just see the diagram. This is how it look like. It is Y shape. R1, R2, R3, they are connected in the shape of Y. Okay, they are connected to the node 1, 3 and 2 and 4. 2 and 4 are together one node only. Just they are stretching, and I shown as a 2 and 4. So which is useful for another type of transformation or another type of network. So here between node 1, 2, 3 and 4, the resistance R1, R2, R3 are connected in this fashion, and this is called your Y network or T network. How it will be tree means just stretch this 1 and 2 when become straight, R1, R2 straight, and R3 on the vertical side, and it become like this. 2 and 4, R3 is becoming like this. Stretch this one, R1 and R2 on the horizontal side, then it become a T network. So the same network can be named as Y or T network. Both are same here. Now coming to the another type of network, that is delta or pi. Now you see here between same 1, 2, 3 and 4 nodes, 1, 2, 3 and 4 nodes, we have a resistance in on the horizontal side RC, and vertical side with an node 1 it is RB, and vertical side with a node 3 RA. So if this is a fashion of topology of a network, then it is how it look like. It is a delta. Okay, it is a delta form. Now why we call pi also. Now just stretch this RB this node to two side, stretch this RA node to the 4 number node side, then it become pi. See, just you have to move this RA this left side and RB on the right and left side like this. Then how it look like? It is a pi network. So that's why Y and T network are same, and delta and pi networks are same. So these are the two types of networks. Now we have to study how to transform these two networks. How to transform these two networks. These networks occurs by themselves or as part of the large network. So these are used in three-phase networks, electrical filters or matching networks. So we have three different applications that are used in three-phase networks, electrical filters or matching networks. So we'll study those in future subjects or in future chapters. What are the three-phase networks, what are the electrical filters and matching networks. Okay, our main interest here is in how to identify them when they occur as part of the network, and how to apply Y delta transformation in the analysis of the network. So we'll study now. Now first one, that is Y2 delta transformation, or delta or pi transformation to the Y to T conversion, that is Y2 or T conversion, the result we want from delta or pi. I will start naming one name only, not two, you may confuse. So I want to transform or convert delta network to Y network. I want to convert delta network to Y network. Here in delta also 3 resistances are there, in Y also 3 resistances are there. Just we are converting it from in this fashion to other fashion. Now what is the definition we can say? Each resistor in Y network is, each resistance in the result Y network is product of the resistors in the two adjacent branches, product of the resistance in the two adjacent branches divided by the sum of the 3 delta resistors. So each resistor in Y network is product of the resistors in two adjacent branches divided by the sum of the 3 resistors. What it is? Let's see. So to transform a network from Y, we create an extra node as shown in figure. Just check here. Now the transform Y network, we create an extra node as shown in figure. The conversion rule will be, see what is given question, that is delta, that is A, B, C nodes, RA, RB and RC are the given, means these are the in the question. Now we want to convert these RA, RB, RC to R1, R2, R3. So to form that R1, R2, R3, we have a extra node here, so that we can have assumption or calculations easy to understand from where to where it is connected, from where to where we have to calculate. So we have to convert this RA, RB, RC delta network, which is in question, and we have to convert it to R1, R2, R3 star, also called as Y network. So now let us take definition. Each resistor in Y network is product of the resistors in the two adjacent branches divided by the sum of the 3 resistors. So each network, each Y network, let's take R1, we want R1. So what is its definition is telling? It is the product of adjacent means beside, product of beside one. So RC and RB, these are the adjacent. So multiply this RB and RC divided by sum of the RA plus RB plus RC. These are the products, okay, and these are the total equivalent resistance of our R1. Check here, R1 is nothing but multiplication of RB and RC divided by RA plus RB plus RC. Same if we want R2. So what is the as per definition? It must be product of adjacent are connected, same node connected delta resistances, or adjacent resistance, both are same. So RB and RA and RC is the multiplication divided by sum of the all resistances. So R2 is nothing but RA RC divided by RA plus RB plus RC. Same R3, if you want R3, it is nothing but adjacent. RA and RB are the adjacent to R3. So multiply these two divided by all the resistances. Simple equation it is. Just how to remember, you have to know. That's it. Means from delta to Y, it is adjacent resistance multiplication divided by the summation of all the delta resistances. This is the called delta to Y network. Now just we will go for the Y to delta network. Let's take. So Y to delta conversion. So in here definition telling that each resistor in the delta network, maybe left side, right side or down side, is the sum of all possible products of Y. Sum of all possible products of Y resistors taken 2 at a time, means products are there, but at a time 2 resistance must be the product, not all the 3 resistance product. 2 resistance at a time must be a product, and their sum divided by the opposite Y resistor, divided by the opposite side of the Y resistor. Now let us take this is star is given, R1, R2, R3 are given. Now we want RA, RB, RC, the this delta we want. So what I am telling, if let us take we want RA. Now if you want RA, then we have to just multiply R1 R2 plus R2 R3 plus R3 R1, then divided by Taqsim opposite side of this resistance. RA we want, opposite side is this one, not R2 or R3, opposite side of this is R1, so divided by R1. So see here, so RA is nothing but R1 R2 plus R2 R3 plus R3 R1 divided by opposite sides of the resistance. In the previous case, the denominator, in the Taqsim denominator, R1 plus R2 plus R3 is the common for all the conversion, but in the in this Y2 delta, numerator on the top side is common for all the resistance, only denominator will change. There only numerator is changed, now here denominator will change. RB, what is RB? It is nothing but multiplication of 2 at a time resistance, that is R1 R2 plus R2 R3 plus R3 R1 divided by opposite side of this resistance. RB we want opposite side, R2 opposite side of the resistance. Same RC, opposite side is R3, so opposite side is down, everything is same on the top. So like this you have to calculate. Y and delta networks are said to be balanced when they are balanced, when R1 R2 R3 are same and it is given by RY, when and RA RB RC are given and is given by R delta. So RA RB RC resistance belongs to delta network, R1 R2 R3 resistances belong to Y network. So these are equal, then they are called balanced. Then I can denote this all 3 resistances of Y network as RY and delta network as R delta, RA RB RC as. Now if you go substitute these values in this, what happens? See, now substitute this RA RB RC. Now substitute R1 R2 R3 as RY. So now substitute R1 R2 and R3 as RY. So this become RY everywhere it become RY. So RY square, RY power 2, RY power 2 divided by R1, that is RY. So it become 3 times RY divided by RY. So RY cancel, it become 3 RY, means RA. What is RA? Is nothing but R delta. So R delta is nothing but 3 times R star or R Y network. So like this, if you substitute in the previous one also, it is R delta by 3 will come. So now what we substituted here, it become R delta. R delta is nothing but 3 times RY. Now take the 3 this side, then it become RY is equal to R delta by 3. Or you can substitute the values of these in the previous what we called delta to Y transformation. Its same result will come. So like this we have to find. Generally for assuming, we can say Y connections are like a series connection and delta connections are a parallel connection. Okay, so now come to the problem. Convert delta network to the equivalent Y network. So this is your delta network. Now I want a Y network. So Y network is how we will form from A, B, C. We form a extra node N here, and one is resistance here, one resistance here, and one resistance here. Okay, for RA and RB, R1 let us take, R2 like this, anything you can take, but we have to connect a 3 resistances in between. Okay, so like this we have to connect with the extra node. You can assume this is as R1 and you can take this as R2 and this is as a R3. Now what is the definition for the delta to star? Delta to star, I told you, adjacent side multiplication divided by sum of the all resistances. Adjacent side of these R1, this R1 adjacent side is 10 and 25, so 250. 250 divided by sum is nothing but 25 plus 10 plus 15, 50. So 250 by 50, 5 ohms. So like this we have to find like this. 10 into 25 adjacent, 10 into 25 divided by 15 plus 10 plus 25, 250 by 50, 5 ohms it's coming. Now same thing, R2 adjacent, 25 and 15 are the adjacent for this R2, divided by sum of the all. See, 25 and 15 are the adjacent for the R2 and divided by sum of the all, RA plus RB plus RC. Now it becomes 7.5. Same thing, R3, it is adjacent is 10 and 15, it must be multiply. 10 and 15 multiply divided by sum of the all resistances, it is 3 ohms. So like this we have to calculate all the transformation from delta to star. If it is delta is given, we can go for the star, and if star is in the question, you can go for the delta. So all equations are with you. Now we will go for the summary. Now in the chapter 2, what are the items we studied? We have some summary, small summary. So we studied of the Ohm's law, that is V is equal to IR. Now Ohm's law in terms of power, voltage, current and resistance, you can have a pie chart like this. So all are the equations are given here with I, V and P and R. Now another method also we have, that is called matrix table, Ohm's law matrix table. Same voltage, current, power and R, if when they are included, these are the table. When current resistance is known, we must know what is V, that is IR. What we must know power in terms of current and resistance, I square R. Like this, all equations are there. If you want, you can just take a printout and you can put on the somewhere in the wall on your room, so that every time when you come and enter, you can see it and you can remember it. So this is the pie chart and the matrix table. Now coming to the some statements. See, Kirchhoff's current law and Kirchhoff's voltage law also we studied. What is the Kirchhoff's current law? Currents entering in the node equal to currents leaving the node. See, I1 plus I2 plus I3 are the entering, and I4 and I5 are the leaving. So this is equal to 0. Now what is Kirchhoff's voltage law? Kirchhoff's voltage law is nothing but the sum of all voltage drops around the loop is equal to 0. Now let us take, this is the one loop and we have 1, 2, 3, 4 branches. A, B, C, D are the nodes. Then with first node, if we are starting with A, so the voltage will be VAB for this branch, then VBC second, VCD third, VDA fourth. So all the voltages must be 0. VAB plus VBC plus VCD plus VDA equal to 0. So now have some summary again. A short circuit, what is a short circuit? It is a perfectly conducting wire with resistance 0. Whenever you ask what is a short circuit, means R must be 0, all electrons are freely allowed to pass, no stoppage. And what is an open circuit? Then it is called infinite resistance, R is equal to infinite, means no electrons are passed, they are stopped. So this is a open and short circuit. Now what is the conductance? Conductance is the reciprocal of the resistance, G is equal to 1 by R, or we can say X, inversely proportional or reverse of the resistance. Now a branch, what is a branch definition? Is a single two terminal element in electric circuit, we know it. Now node is a point of connection between two or more branches. If two are connected, it is series. If more connected, they are in parallel. A loop is a closed path in a circuit. With this also we studied. Now what is the topology of between these three? Branch, node and loop is nothing but branch is equal to loops plus node minus 1. When elements are in series, the sum current flows through them, I1 is equal to I2, the same current flows through them, sorry. So when elements are in series, the same current flows through them. If the first element we are calling as I1 and second element we are calling as I2 current is flowing, then I1 must be equal to I2. Parallel voltage is equal. When elements are in parallel, the same voltage flow across them. That is, first element V1, the second element is V2, then V1 is equal to V2. Here element and branch both are same here. So when two resistance are R1, that is reciprocal of G1, and R2 reciprocal of G2 are in series, then it is R equivalent. When two resistance are in series, what is that? R1 plus R2, and G equivalent will be G1 G2 by G1 plus G2. Same opposite to the parallel. Then parallel R equivalent will be R1 R2 divided by R1 plus R2, and G equivalent will be G1 plus G2. So this is how we studied the all the items. Now come to the voltage division and current division. The voltage division principles for two resistors in series is nothing but it's the same resistance multiplied by voltage divided by the total resistance, and the other voltage is its same resistance multiplied by voltage divided by the total resistance. and current is the in parallel is nothing but it's other resistance multiplied by the total current divided by the total resistance. It's I2, it's other resistance multiplied by the total current divided by the total resistance. It is the current division. It is quite opposite. These two are quite opposite, series and parallel. The formula for delta to Y transformation are R1 is nothing but adjacent side resistance multiplication divided by the total resistance. Adjacent resistance multiplied by divided by total resistance. R3 also adjacent resistance multiplication divided by total resistance. But in the Y to delta transformation, it is the multiplication of two at a time combination multiplication plus all the resistances divided by the particular opposite side of the resistance, opposite side of the resistance. So like this we have R1 R2 plus R2 R3 plus R3 R1 common for all the three, and divided by is the opposite resistance. So like this we have star delta transformation or Y delta transformation or delta to Y or Y to delta transformation. Now we have some problems which is given. All are based upon your Kirchhoff's law and KVL, Kirchhoff's voltage law and Kirchhoff's current law and Ohm's law, and on these equations only these all problems are related. And one thing we have to see that step by step you have to complete the circuit. Now another set of problems are to reduce the big circuit to the equivalent circuit. Means we have many resistance are in series and parallel, so make it the single resistance, make it to the one resistance network. That is, more resistance are there, just solve series to parallel, parallel to series, then make it to one resistance. So those problems also included here. This is uploaded in the blackboard, you can just go through. Here in the last slide we have the star to Y to delta and delta to Y transformation questions also there. Okay, for the next class we have the quiz. On the quiz, chapter 1, chapter 2 till last class what we study. In quiz, delta to Y and Y to delta is not there, so no need to study about this for the quiz. For the mid exam, final exam, you have to study that one. Okay, so this is how we have to complete the chapter 2.